In this lecture, I'll talk about how to use the Texas Instruments BA2 Plus financial calculator. We will talk about basic setup, how to calculate the future value of a single payment using annual compounding, multiple compounding periods a year, continuous compounding. We'll talk about how to calculate interest rates and number of periods. We'll talk about the present value of a single payment, the future value of ordinary annuity, present value of ordinary annuity, future value of an annuity due, present value of an annuity due, net present value of an uneven cash flow, future value of uneven cash flows, the internal rate of return of an uneven cash flow, standard deviation and mean, and then some miscellaneous topics at the end. By the time you're done with this tutorial, you will have a good sense for how to use the Texas Instruments financial calculator. Let's start with some basic setup. If you've not done so already, what you need to do is set your calculator so that it's on decimal places equal to 9. The way you do this is press second and then the format button, which is right here. And then you might see, if you've not done this before, you will probably see decimal equal to 2. Change that to 9. So set decimal equal to 9. So you enter 9 and then you hit the enter button. So basically what you've set the calculator now to is something called floating decimal, which effectively means that the calculator just goes to as many decimal places as necessary. In my experience, that is the best way to go. And then once you have set decimal equal to 9, just press second quit, and now that returns you to the regular calculator mode. You just need to do this once, and then unless you reset later, this is where your calculator will stay. Important first step. Okay. So now let's talk about calculating the future value of a single payment. Let's say you invest $100 today at 10% compounded annually. How much will this become after 5 years? So if we draw a simple timeline, at time 0 you are investing 100. The question is, what will this be at the end of 5 years given a 10% return? The way you do this second quit, just basically make sure that you are in regular calculator mode. Then you need to get into then the next thing you need to do is just clear the time value of money worksheet. The way you do that is hit the second button, which is here, and then clear TVM, which is here. So this clears your TVM worksheet. Just in case you have some numbers from before, this removes those numbers. Then you enter 5. So 5 and then N. Basically, we will be working with this row now. So this is basically your time value of money row. So you enter 5N. After this, if you want, you can hit the enter button, but it's not necessary. When you do cash flow related stuff later or statistics, then you have to enter. Then you have to hit the enter button. But for TVM, enter is optional. If you forget where to do it, where not to do it, just to be on the safe side, you can just hit enter over here. But if you forget, it's not a big deal. As long as at the end, after saying 5N, your display should say N equal to 5 over here. So you should see N equal to 5. Then you hit 10, which is your interest rate. So your keystrokes are 10 and then interest rate. And on the screen, you should see IY equal to 10. So that's set your interest rate to 10. 100 PV. This is basically setting your present value to 100. So it is saying that you are starting with 100. And on the screen, you should see PV equal to 100. Then 0 payment. This basically is saying that there are no payments in between. And on the screen, you should see payment equal to 0. And then once you have entered your information, then you just hit the compute button and you hit future value, and what you will see is minus 161.051. Note the minus sign. The reason there is a minus is that if you put in a positive number over here, the calculator assumes that you are, let's say, putting money into a project, and then at the end of 5 years, if you are taking money out, that's money in the opposite direction, and the sign then will be opposite to what you had put in the beginning. Had you entered PV is equal to minus 100, then you would have had a positive sign for the future value. Alright, so let's now, so what we just did was we found the future value. What if you are given your initial amount of 100, you are told that after 5 years you will have 161.05. How can you find the interest rate? The process is more or less the same. Second, quit just to make sure you are in your regular calculation mode. Clear your time value of money by doing this. And then enter 5N. So enter all the information that you have. So 5 periods, present value of 100, payment of 0. Now you enter the future value. Make sure that the future value is 161.05 plus minus, which means that you are entering a negative number. The present value and future value need to have opposite signs. If you don't do this, you will get the dreaded error 5. Okay, so make sure you have these two in opposite signs, and then just hit compute IY, and that will give you an interest of 10%. What if your money is compounding every quarter? So again, take a similar problem, $100 invested today at 10%, but now the money is compounded quarterly. So how does this work? Now basically we are saying at time 0 we invest 100, and this is the 5-year mark. But let's say this is 1, 2, 3 years and so on. But each year now is divided into 4 quarters. So how many quarters do we have? The number of quarters is 5 into 4, which is 20. And if the stated annual rate is 10%, the quarterly period will be 2.5%. So that's the interest rate for each period. Now you basically do what you did before. Second, quit to make sure you are in regular calculator mode. Clear your time value of money worksheet, and then 20N. So this is basically saying that we now have 20 periods, and then 2.5 I-Y. So this is saying that you are entering that your interest rate for each period is 2.5%. So that sets your interest rate to 2.5% for each period. 100 is your present value. So you see this payment is 0 because no payments are happening in between. And when you compute future value, you get minus 163.861. Notice that this number is slightly higher than what we had before, which is what you would expect because the compounding is happening more often. Future value of a single payment when you have continuous compounding. So now let's say that the money is compounding continuously. So you invest $100 at time 0 and the stated rate is 10%. How much will you have at the end of 5 years, assuming continuous compounding? Since we have continuous compounding, the concept of number of periods does not exist because money is compounding every instant. So the formula that we use here is the future value is equal to present value times e to the power of RT. R is the interest rate, T is the time. So what's your present value? Present value is 100. And e to the power of r is 0.1. So you actually put in the decimal version of the rate, and t is 5 years. So 0.1 into 5, which is 100 times e to the power of 0.5. So what you do here is you have to use the e to the power of x button, which is right here. So to use that, put in 0.5, which is right there, and then second e to the power of x. So second and e to the power of x. This will give you 1.6487. Just multiply that by 100, which is your present value, and you will have your answer, which is 164.87. Present value of a single payment. So now let's go in the opposite direction. So let's say you will get 161.05 in 5 years. Interest rate is 10%. What is the present value? So the timeline is like this: time 0, time 5. At the end of 5 years, you are going to get 161.05. Interest rate is 10%. The way you do this on your calculator, clear your TVM worksheet, and then 5n, so that's the number of periods, 10 interest rate, so set your interest rate to the given number, which is 10%. Set your future value to 161.05. That's this number. On your screen you should see FV equal to 161.05. Zero payment because there are no payments in between, and then simply hit compute and present value, and this will give you your present value of minus 99.999, which is practically 100, which is what we saw before. Again, I am harping on this point because many people mess it up. Notice that the future value and present value have opposite signs. Now let's talk about the present value of a single payment assuming continuous compounding. So say you will get 164.87 at the end of year 5, and we are using a 10% interest rate with continuous compounding. What is the present value? As we've seen before, the present value formula is present value is equal to future value into e to the power of minus RT. Plugging in the numbers, the future value is 164.87 times e to the power of minus R is 10%, which is 0.1, times t, which is 5, so raised to the power of minus 0.5. The way you plug it in the calculator, put in minus 0.5, second e to the power of x, so second and then e to the power of x, and you will get 0.60653. Simply multiply this by the future value, which is 164.87, and you will get your present value, which is about 100. The future value of an ordinary annuity. So say you invest $100 at the end of year 1, year 2 and year 3, compounded at, so interest rate is 10% compounded annually. What is the future value at the end of 3 years? Let's first make sure we can do a timeline for this. So time 0, time 1, time 2, time 3. Interest rate is 10%. At the end of year 1, we have 100, then 100, then 100. So the future value means the equivalent amount of these 3 cash flows at this point in time. So the way you do this is make sure you are in regular calculator mode, clear your time value of money worksheet, and then plug in 3n. So that's saying that we have 3 periods. So here again we will use this row over here for time value of money calculations. So set n equal to 3. Then you type in 10 and then your interest rate. So that sets interest rate equal to 10%. Your present value is 0. That means that you have not invested anything at the beginning. The payment is 100. So that means that you are making payments of 100 every year for 3 years, and then compute the future value, and you will get minus 331. So future value is 331. Notice that since the payments were entered as positive numbers, the future value will be given as a negative number. Had you put in negative 100, negative 100, negative 100, the future value would be positive 331. So now we'll talk about the present value of an ordinary annuity. Let's say that you get $100 a year, every year for 3 years. So times 0, 1, 2, and 3. So $100, $100, and $100. Interest rate is 10%. What is the present value? So these steps you've seen multiple times before. Then set 3n, so number of periods is 3, 10 is your interest rate, so that gets set. 0 future value. This means that other than the 3 payments of 100, there is nothing else that is happening at the end of 3 years. The 100 payment, so that's specifying end of every year you have a payment of 100, and then compute PV. That gives you a present value of minus 248. So present value is minus 248.685. So this number represents the present value of these 3 cash flows. What's the future value of an annuity due now? Now with an annuity due, payments happen at the start of the period. So let's just draw the timeline. 0, 1, 2, 3. So now the 3 payments are happening at the start of year 1, start of year 2, and start of year 3. The future value of this annuity, where there are 3 payments, the future value would be the future value of these 3 payments at the end of year 3. The simplest way to do this on your calculator is to first set your calculator or put your calculator into begin mode. Begin mode means that the calculator will assume that the payments are being made at the start of every period. So to put your calculator into begin mode, you hit second and then begin. So the begin key is right here. So second begin, and then again second and set. So you put your calculator into begin mode, and once you've done this, you will see a small BGN at the top right of your screen. And then to get into calculation mode, you do second quit. So now you can start calculating with the calculator in begin mode. You then clear your time value of money worksheet, plug in 3n, which says that there are 3 periods, plug in 10 IY, which is setting your interest rate to 10%. There is no PV, so that is saying that other than the payments of 100, 100, 100, there is no other initial present value that you are using. So PV is 0, and then payment 100. So here you are telling the calculator that the payment amount is 100. You've already told the calculator that there are 3 periods. So effectively you have entered this cash flow into the calculator. When you now compute future value, you will get minus 364.1. So that is the future value. So the sum of the future value of these 3 cash flows is 364.1. And as I'm sure you know by now, since you entered 100, 100, 100, the future value that will be calculated will be shown as a negative number on your calculator. Okay, what if we have uneven cash flows? So take this example where your cash flow at time 0 is minus 100, and then at time 1 is minus 50, then 2, and then end of year 3, 0, and year 4 is 200. So if this were actually this is like a timeline. So all these are end of period payments. These are end of period payments and these are cash inflows. End of period 0 is the beginning of period 1. So this is the start of a project. Let's see how we will enter this data. The area that you will now be using is this. For this and the next slide, we'll be using the cash flow register, which is based on what I have just outlined. So what are your keystrokes? The first thing you do is get into the cash flow register by clicking the cash flow button, which is right here. And then you want to clear any work that's already, any numbers that are already stored in your cash flow registers. You do that by clicking second and then clear work. So second and clear work over here. So this clears all your cash flow registers. Then you enter this data. So you put in 100, and since it's a negative number, you then put plus minus. And when you do cash flow related entry, you have to press enter. After pressing enter, you will notice that your register will say cash flow 0 is equal to minus 100. If you don't see an equal to sign, that means that the system has not accepted your entry. And typically, if you don't click the enter button, there will be you won't see the equal to sign. Then hit the down arrow and 50 for the next entry. That's also a negative number, so put in plus minus, enter. That's your period 1 cash flow. Then using the same logic, you enter your period 2 cash flow. There should not be any plus minus over here. So enter your period 2 cash flow. Then actually an important point to note here, why are we asking you to hit the down arrow twice? The reason is that after you enter cash flow 01, you press the first down arrow, you will notice something called F01. This stands for frequency. This is saying how often is this cash flow of minus 50 happening. And you'll notice that the default should be 1. If it is not 1, then explicitly set F01 equal to 1 and hit enter. If you already see F01 equal to 1, then just hit the down arrow and move on. And then when you hit the second down arrow, you will see cash flow 02, put in 100 and then hit enter. So you've now told the calculator that the second cash flow is 100. Then when you press the down arrow, you will see F02, set that equal to 1, which is saying that this cash flow of 100 has a frequency of 1. You press the down arrow again, you will see cash flow 3, explicitly enter 0 and then hit the enter button. If you don't enter 0, then the calculator gets confused. So make sure you enter the 0 and then hit the enter button. And then again down arrow twice, press in 200, which is your fourth cash flow. So this should be cash flow 4. And then you press your down arrow and hit the NPV button. You will then see, when you hit the NPV button, you will see I equal to 0. There you put in 10, which is telling the calculator that the interest rate is 10%. Then hit enter. So what you have now done is told the calculator that you are calculating NPV with an interest rate of 10% and with all this cash flow that you have entered. You then hit the down arrow again and hit the compute button, and the calculator will then give you the net present value, which is 119.247. So this is the net present value, 119.247 is the net present value of this entire cash flow. Now, if any of these cash flows had been repeated multiple times, so for example, in year 4, 5, and 6, if you had 200, 200, 200, then what you could have done is after entering 200, you could have specified a frequency equal to 3. But in our case, all the frequencies are simply 1. If you don't like to use the frequency button, you can just enter 200 3 times and maintain a frequency of 1. Okay, now how do we do the uneven cash flow with how do you calculate the IRR for this cash flow? What you do here is the same data entry. So all you're doing is entering your cash flow, first cash flow minus 100, second cash flow is minus 50, third cash flow is positive 100, the fourth cash flow is so that's the second, the third cash flow is 0, and the fourth cash flow is 200. So you enter your cash flow and then you compute. So then you, after entering your 200, so this up till here we've done exactly what we did with NPV, but for this calculator here we want to find the IRR. After entering 200, you hit the down arrow and then hit the IRR button and the compute button, and the system will calculate your IRR, which is 41.42%. Now let's move to standard deviation for a population and a sample. Let's say that you are given 4 data points, 15, minus 5, 2 and 22, and you want to find the sample standard deviation and the population standard deviation for this data. How do you do that? You can do this the long-winded way using the formulas for standard deviation, but here we will look at a fast way of doing this using the calculator. The first thing that you do is get into the data mode by clicking second, and then data, which is right here. So second data, you will then see x01 equal to, if you've not entered anything before, you will see 0. But in case you see something there, or just to be safe anyway, click second and clear work. So that clears all the data items. Then you start inputting this data. Type in 15 and enter. So what you've done is set x01, the first x value, to 15. You hit the down arrow, and when you hit the down arrow, you will see a y01 equal to 1. In our case, since we are just dealing with one data set, we will ignore the y's. So we ignore the y's by just clicking the down arrow again. And we now want to enter minus 5 plus minus. So we are now saying that x02, the second x value, is set to minus 5. Keep going the same way, ignore all the y's by just down arrowing through them, and essentially you need to input all this data. So once you've entered this data, here we simply have 4 data points. You could have more than that if necessary, but in our simple example we will work with 4 data points. You then hit, after entering the 4th data point, do down arrow again and then second and stat. So second and stat is right next to the data button. Second stat, and then hit second set until you see, maybe after entering this, if you see 1-5 on your screen, then you're good. If not, then hit second set until you see 1-5 on your screen. So when you see this, this means that the calculator has determined the necessary statistical values. So now when you hit down arrow, the first thing you will see is n equal to 4. This means that 4 entries were made. Hit down arrow again and you will see x bar equal to 11. That means that the average of the data that you entered is 11. Hit down arrow again and you will see sx equal to 11.46. Sx is the standard deviation for a sample. So if these 4 data items represent a sample, then the standard deviation would be 11.46. If you wanted to find the variance, the variance would simply be 11.46 squared. Then the next item, when you press the down arrow, will be sigma. The sigma is the standard deviation, assuming that these 4 data items represent the entire population. So this will use the standard deviation formula that is applied to a population. And again, if you want to find the variance, you can simply find the square, which is 9.92 square. So that's a quick and easy way of finding the standard deviation. And now finally, let's just go over some miscellaneous topics before we wrap up this tutorial. So memory, how do you use calculator memory? The calculator memory is basically these two store and recall buttons, and it's quite simple to use. You can think of the calculator as having 9 places where numbers can be stored. So let's say you want to store the number 10. So on your calculator, type in 10 and then store 1. So 10 and then store 1. So what this is saying is that in memory space 1, the number 10 has been stored. So now if you click clear and then you click recall 1, so you click this recall button, you will notice that recall 1, the number that will appear is 10. Now similarly, if you do 20 and then store 2 and then you hit recall 2, the number that will show up is 20. Now you clear again and then hit recall 1, the calculator will again show you 10. So not a huge big deal, but if you like to use the memory function of your calculator, it's basically the store and recall button. The recall button is also useful when you are doing time value of money work. So remember, time value of money is this stuff, these 5 buttons. If you are doing time value of money calculations and you want to see what is the value for interest rate that your TVM worksheet is currently using, all you need to do is say recall and then so hit the recall button and then hit the interest rate button, and up here the calculator will display the current value of interest rate that is being used by the calculator. Permutations and combinations. So let's say you want to calculate 8p3 on the calculator. The way you do this is you type in 8 and then second NPR and then 3, and this will give you an answer of 336. If you want to do combination, let's say 8C3, you type in 8 second and NCR, which is right here, and then 3, and you will then get 8C3 equal to 56. And the last little useful button I'll talk about is the backspace button. Say you are entering 1527 and by mistake you enter 1528. Rather than having to enter the whole number again, you can just hit the backspace button. That will erase the 8 and then you can type in 7. Comes in very handy. So that is it. What I have talked about is an overview of the calculator, and for me this information has worked very well. There are other functions in the calculator, but to be honest, I have never used them and have never felt the need for them either in any of the 3 CFA exams. As always, take the material that we've talked about and practice it a lot until you are extremely comfortable with your calculator. That's it for now.